We gratefully acknowledge that we are gathered today on the ancestral lands of the indigenous peoples who have stewarded this place since time immemorial. Valley of the Gods, part of Bears Ears National Monument, is situated on the ancestral territories of the Hopi Nation, Ute Mountain Ute Tribe, Navajo Nation, Ute Indian Tribe of the Uinta and Ore, Zuni Tribe, and other communities. Join us in honoring the wisdom, resilience, and enduring contributions of the Native people who have cared for this land, and the diverse and vibrant Native communities who make their home here today. Hello and welcome to the broadcast. We are live from Valley of the Gods in Bears Ears National Monument, and you are looking at an image of the sun in real time. My name is Julie Yu, and I'm here with my colleague Desiree Whitmore.
Hey.
And we're both scientists at the Exploratorium, which is a science museum in San Francisco where you can experience and engage with natural phenomenon. We're here in Utah this morning because this is where we will be able to experience an annular solar eclipse. Now, a solar eclipse happens when the moon passes between the Earth and the sun, blocking some of the sun's light from hitting the Earth. The telescope image we just looked at looked like the sun had a giant bite taken out of it. That dark portion was actually the moon, and over the next half hour, that moon is going to continue to move until it sits in the space right in the center of the sun. That moment is a moment we call annularity because it's going to leave a ring of sun around the moon. We have telescopes set up in two locations where this is going to happen today, here in Valley of the Gods and also in Ely, Nevada. As the moon moves today, it's going to trace a path across North, Central, and South America. And those that are in the path of the moon's shadow will be in the path of annularity. They will see the annular eclipse. Those outside of the path, but still in these areas, will be able to experience a partial solar eclipse. That's the case for folks back at our home in San Francisco. We've brought an entire production crew to be right here in the path of annularity so that you can witness this event wherever you are.
That's right. We've got high-powered telescopes, we've got cameras feeding into production trucks, feeding into 4 satellite dishes, beaming up to 2 space satellites, all to bring you the very best live coverage of what's going on today. And this is nothing new for the Exploratorium. We've been doing this for over 25 years, sending expeditions out around the world to chase and capture eclipses. And our partnership with NASA has actually helped us to broaden our audience so that we can bring more and more people to the eclipse wherever they are. And this year, the eclipse is actually passing over Navajo Nation, which gives us the amazing opportunity to welcome today 2 of our partners from the Indigenous Education Institute. We have both Dr. David Begay and Dr. Nancy Maryboy, I'm very sorry, who are astronomers, educators, and community elders, and they're going to welcome us to this beautiful place today. Welcome.
Yat-e abine. Good morning, everybody. We're so excited and so happy to be talking to you all around the world. This is just an amazing experience today. I want to welcome you especially to this land that we're standing on. This is my homeland, my family's homeland, and if you look this way, you're going to see a hill. You may not see it the way I'm seeing it, but there's a hill in front of me, and on the other side of that hill is our family land. And we're so excited to be working with the Exploratorium. We're so excited. We also work with NASA HEAT, and we come from the Indigenous Education Institute. This is an awesome time. People are revering, are being reverent already here. It's very quiet, and we just welcome you with all our hearts to be here with us.
Thank you.
I want to greet everybody by my traditional language, native language. I want to say Yat-e. Yat-e refers to the universe. The Net people, they're cosmic thinkers. So Yat-e refers to the cosmic world, the cosmic motion, the natural cosmic process, and our existence, the human is a participant of a much bigger universe. All the movement, cosmic movement, we're a part of that movement. And I wanted to greet you, all of you, by that word, Shikeya. Also, welcome to the Navajo country. In the back of me, there are these red mesas. All of this was considered traditional Navajo land, and it still is. I want to welcome all of you, and our connection to the earth is very important. That's how we say Shikeya. And so that's I wanted to greet you from this place, from this country, from Navajo land, from the Navajo Nation. I wanted to reach out to everybody. I think this is a very special time for all of us.
Thank you so much both for this wonderful welcome. It's a pleasure working with you. Now let's check out the telescopes and talk to Robin.
All right. Hi, everyone. I'm Robin from the Exploratorium. We're looking at beautiful live images of the sun right now. And I'm joined by Dr. Eric Christian. You're NASA's senior research scientist on the Parker Solar Probe mission, which is one of the coolest missions that NASA has ever run.
It's a great mission. We're dipping down into the atmosphere of the sun for the first time ever.
Okay, so let's talk a little bit about where we are in this eclipse right now. So if you look at the image from the telescope, it kind of looks like a big bite. As I think Desiree said earlier, big bite's been taken out of it. Where are we?
So that's the moon blocking part of the sun. So we're in the first partial eclipse phase. In a little while, the moon will move entirely in front of the sun, and that's when we get the ring of fire annularity. That'll only last for about 4.5 minutes. Then the moon will continue to move, blocking part of the sun. You'll get another partial eclipse for about an hour. It's about an hour before and an hour after that you'll see partial eclipse, and then eventually the moon will move completely off the sun.
Excellent. And speaking of the telescope images, how are we making those? Could you tell me a little bit about the telescope?
So we have 4 telescopes here. There's a telescope that shows the white light, which is what basically the human eye sees. We have one that zooms in white light. There's the full sun white light. There's a zoom in of the white light that shows a close-up. And then we also have a single wavelength of light called H-alpha. We have the full sun H-alpha, and we also have a zoom-in close-up H-alpha. The H-alpha shows a lot more details on the surface of the sun.
Yeah, just on that image, that is so beautiful. Those bright parts, what is that?
Those bright parts are actually active regions, sunspots. They look, in H-alpha, they look bright, but if you're looking in the white light, they appear as sunspots. And if you look through eclipse glasses, these are a little small to see with your eye, but if they were big enough, you'd see them as sunspots.
Excellent. And the other question is, they had showed us a map of sort of the path moving across the country. So we have a crew in Ely. So that image is going to be different than ours?
So Ely is earlier on in the path, and so as the moon's shadow moves across the country, it'll pass over Ely first and then come to us. So their time of annularity will be before ours.
I see. So they just have annularity earlier.
Yes.
Interesting. Okay, and finally I would say, I can't help but look. The sun with these glasses looks amazing, but it is a different view from what we're seeing here on our monitors. Could you talk about that for a minute?
So that's the reason why you use a telescope, is because it zooms in, it blows up the image, and you can see more detail on the larger sun. That's the difference between the human eye and the telescope.
Great, and it's nice to have both, because
Yes.
there's nothing like seeing it with your own eyes.
Seeing your own
With
eyes is great.
glasses.
Yes, with glasses. You have to protect your eyes during an annular eclipse. Even during the annularity, unlike in a total eclipse, you have to keep wearing your eclipse glasses.
Great, thank you so much. So now let's turn it over to Desiree, who's got a little hands-on activities for us.
Thank you. And that's right. You have to wear your safety glasses while you're looking directly at the sun. And your safety glasses need to meet the international standard, which you can find right on the inside, written somewhere. But if you don't have glasses, that's totally fine. I actually have helpers today. I've got Nadia and Clara May, who are our Northern Arapaho partners, and they were going to help me demonstrate for you how to see the eclipse without looking at the sun. All you need at home is some kind of object that has a bunch of small holes in it, or even just one. And so you can have spoons or baskets or colanders or anything you need. So if you look at the screen right now, what you see is a picture that we took yesterday that shows what the eclipse or what the sun looked like through a pegboard. And what you see are circles on the screen because that's what the sun looked like. But now, if we look at the same exact pegboard that Clara May is holding up for us, what we see is really cool shapes. And what those shapes are representative of is the sun. So what you are seeing is a pinhole image, the sun, the total solar eclipse flipped upside down. And of course, we can also look at baskets that have like square holes in them. And as Nadia pulls it away, you also see these same kind of crescents in all of the little shadows. Now, we also asked Clara May and Nadia to create these beautiful necklaces for us in order to honor the eclipse. So can you ladies tell me a little bit more about these necklaces?
Yes, so today we have commissioned medallions for the NASA group to help educate the phases of the eclipse. So we have the pre-annularity, the annularity, and the post-annularity. We also commissioned a medallion for the first Native American woman astronaut, Commander Mann.
Nice. And how long have you been beading?
So my grandma taught me when I was really young, and I have been beading ever since then.
That's amazing. Are there any other cultural practices of the Northern Arapaho around the eclipse that you'd like to share with us?
Yeah, so my late grandfather, George Moss, he was one of the 4 old men that is the medicine man known to the Northern Arapaho tribe. Every summer, the first month of July, they hold a ceremony called Sundance, where men and women, they go and fast for 3 days without food and water. And my grandfather would go paint on his grandsons the eclipse in the middle of their chest where the sun holds, and at the moon on their back. And as the day goes by, the last day is the full annularity.
So cool. I can totally see that here in the necklaces that you've created. You all are very talented. Thank you so much for helping me.
Thank you.
And so now we have a video that we have created. We're going to share with you a short excerpt from a video that we made in collaboration with the Indigenous Education Institute and the Little Singer Community School. For the full video, you can go to our website. This video is going to help us understand more about the Navajo cultural practices around eclipses.
Even the greatest powerful thing in our universe, our Father, the Sun, has to die. And so that's when we call upon today as the solar eclipse. And so the sun, we call it Johana E Dazza, our Father, the Sun, dies.
Our elders tell us that the sun, the moon, and the earth, they go through constant renewal by aligning themselves. The sun rebalances itself also whenever that eclipse happens.
So when you think about eclipses, it's like it depends on the tribe you're talking to. So if you're thinking about Navajo, the thoughts are it's part of the natural order. And unlike some other tribes, Navajos have very traditional protocol that involves the eclipse, and part of it is this whole idea of reverence and respect for what's happening in the sky.
According to our elders, it has an effect. The eclipse has an effect on everything.
Hey, the Sabina Dogas, Nalas la de la Titan Stain Dolly. Ye didn't sting ye. So that's so. Yeah, Baos are. Dina dar aside the trago. Lal close at low na rago. Eh, didn't slide of Donishi. A co did Khatas are only.
And so traditionally Navajos would come in from the outdoors, come into their hogans or homes, and they would sit very silently in reverence. You wouldn't eat, you wouldn't drink, and many, many traditional peoples follow that today. it's a movement that you're reverent and you're honoring that.
We have to be holy, which means we have to behave and be respectful. If it was a sun eclipse, then we would have to close all the windows, and it can also affect you by your stomach and eyes. The Ned people are told they can't move, only sit still until the sun and moon come apart.
Thank you again to our friends at the Indigenous Education Institute in the Little Singer Community School. I want to check in on the telescopes today because we just noticed it's starting to get a little cooler in temperature, and you can see that the moon has moved even further over the sun, leaving what now looks like a crescent sun. And we're used to seeing crescent moons normally, probably because you've noticed the phases of the moon. You might remember that 2 weeks ago there was a big full moon. I actually remember this because it was Mid-Autumn Festival, which is a harvest celebration for many Asians and Asian Americans. It goes by different names, but it always happens on the full moon after the harvest. Now, in order for us to see a full moon, the moon has to be on the opposite side of the Earth from the sun. And I have my scale model Earth and moon here, and at this scale, they would actually be like about this far apart, but I'm going to hold them a little closer just so it's easier for us to see what's going on. So the sun is over there for me. You might be able to see my shadow. And again, in the full moon, the moon is on the opposite side of the Earth from the sun, but it's now 15 days later, and the moon has come around so that it's now sitting between the Earth and the sun. We call this phase of the moon new moon, and we don't see it in the sky because the sunlight reflects off the moon back into space instead of back into our eyeballs on Earth. When the new moon comes, if you think about a line between the Earth and the sun, the moon can pass above that line. Sometimes it passes below that line, and sometimes it passes right through that line, and that is when we have a solar eclipse. That special moment when three objects line up in space is called syzygy. And in that moment, the moon blocks some of the sunlight from the sun reaching the Earth, casting a shadow on the Earth. And folks in that shadow will be the ones who experience a solar eclipse. So this only happens at new moon, and not every new moon, because sometimes it misses the line and there's no eclipse. Sometimes it just blocks a portion of the sun and we get a partial solar eclipse. Every so often it comes right in that line and we get a total or annular solar eclipse. Now, which one of those happens depends on another factor in space, and that is the distance between the Earth and the moon. You see, the moon's orbit is not a circle. It's actually an ellipse. And so the distance, sometimes it gets closer and further away. And if it is closer to Earth, its apparent size in the sky will be bigger. And that's when it's big enough to completely block out the entire sun, and we get the total solar eclipse. If it's a little further away from Earth, as it is today, it won't completely block out the sun. Instead, it'll leave a ring of fire, and we'll see what we'll see today, which is an annular solar eclipse. So depending on where these three objects line up in space, you might see a total, partial, or annular eclipse. It can be a little tricky to notice that the moon's distance from Earth changes, but today we will get evidence that indeed there are moments when the moon is further away from Earth. So we're going to hear next from Desiree and a special guest from NASA about some other things we can learn during eclipses.
That's right. Thank you, Julie. So I'm very happy today. We have Doctora Yari Goyalo Vega from the Moon to Mars Space Weather Analysis Office. That's a mouthful to say. And she's going to help us learn more about the sun. How are you doing this morning?
I'm great. I'm very excited to be here. Thank you for having me here.
Thank you. Can you tell us actually what are some of the things that we're studying about the sun right now?
We study a lot of things about the sun. One of the things that we study right now is the solar cycle. It has its maximum and its minimum. When you have a maximum, you have a lot of sunspots, which actually creates a lot of solar storms and a lot of solar activity. But when you have the minimum, you don't have that many sunspots.
And so what are sunspots?
Sunspots are areas on the sun, regions on the sun that you have a very high intense magnetic field, and the pressure and temperature is actually different than the surrounding area. And they look darker when you look in the white light because temperature is actually lower than the surrounding area.
Okay. And so you mentioned solar storms. Like, what is the other activity that is happening?
There's a lot of activity that happens in the sun, a lot of solar storms. We have, for example, solar flares, which are bright eruptions of radiation. We have coronal mass ejections, which are billions of particles being ejected from the solar corona. Right there that you're actually seeing at prominence. These are areas of solar plasma that actually are in between channels between the photosphere and the solar corona, and they stay there for months sometimes. And then when something happens in the surrounding area, they erupt and they actually can form a coronal mass ejection.
That's amazing. And so when you talk about space weather and solar storms, like why is that important to study?
It is really important because space weather are, in simple terms, the conditions in space that are mostly dominated by the sun's activity. When they arrive at Earth, those solar storms, they can cause a lot of problems in the instruments of the satellites in space, problems in communications, GPS signal loss, power grid disruptions. Right there, you actually see in a video where you actually see the solar flares right there, right now. It's a bright eruption of radiation. And then you can see the coronal mass ejection, which are the big explosions of particles coming out of the solar corona. There's a lot of things that happen at Earth, like I said, and also another thing, the auroras, which is amazing. People love auroras, but when the aurora happens, that means that we have a disturbance in the magnetic field of the Earth.
Wow. And so we are studying that with your space weather analysis office. And so what are some of the things that you're studying there?
So in my office, the office that I direct, that I'm really proud of, we actually do the space weather assessments for NASA missions, to protect NASA missions. And we're actually now validating models in real time to protect the astronauts for the Artemis program, which is the program that is going to go back to the moon and then to Mars.
Hey, moon to Mars. I get it.
Yes,
okay,
moon to Mars.
Fantastic. And I heard that there's a space fleet out there.
Yes. So for us to be able to study the sun, we need to have, ground observatories, but also we need space-based stations, right? So we have a lot of missions. Actually, I shouldn't say a lot because there are about 20 operated missions right now. It sounds like a lot, but if you think about it, this is a huge volume in space that we're trying to study. So, it takes a lot of effort to do that, right?
Yeah. Thank you so much, Doctor. Now, we are going to shoot it back to Julie.
Okay, we're just under 10 minutes to annularity here in the Valley of the Gods, and it's getting cooler and the light is dimmer, but in sort of a spooky way. As you look through the telescopes, you see even more and more of the sun is getting covered. And remember, we have telescopes in Ely, Nevada, where they will experience annularity first. You're looking at a real-time animation of the moon's shadow as it's crossing. And Ely's a little over 300 miles away. It would take about 8 hours by car, but the moon's shadow is moving so fast, it's only going to take 6 minutes between annularity in both points. So we're about to see back-to-back annularities. And as the moon gets close to that moment of annularity, I want you to pay attention to the edges, because sometimes you'll see that the moon's disk doesn't perfectly line up with the sun's disk, and there are little beads of light shining through. Those are Baily's beads, and it's light shining through the valleys that are on the surface of the moon, and they provide us evidence that the moon's surface is not smooth, it's rough. We have Exploratorium's Chief Learning Officer, Rob Semper, live for us in Ely, Nevada, to talk us through annularity. How's it going over there, Rob?
Go to Ely. Thanks, Julie. We're here at the Northern Nevada Railway Museum in Ely, Nevada, and things are getting really exciting here. I'm here with Jeremy Lewan, Eclipse Ambassador, and things are getting really exciting because we're really getting close to annularity. So let's switch to our telescopes right away. You can see we're almost there. The edge is almost of the sun. You can almost see the whole circle. What an amazing experience.
We have the cheering of the crowd behind us. We just had something called second contact. Now the actual whole moon's disk is within the sun's disk, and we see that beautiful ring of fire, annulus, around the sun. Oh my God, around the moon. Excuse me. The sun is just unbelievable. Oh, wow.
This is just incredible. I've seen about 6 eclipses, total eclipses. I've never seen annularity.
And neither have I.
This is an amazing experience.
Amazing. It's so different than totality. You still get this change in lighting. You get the change in temperature. Temperatures drop by several degrees. We can tell the difference. We're actually kind of shaking here.
Exactly.
But unbelievable to actually see the annulus around the moon.
The other thing that's happened is our shadows are really weird. We're getting really weird shapes in our shadows. If we look behind us, because of the sun's occultation. The shadows are very strange. It's really exciting, but it's a lot lighter than it is during a normal total eclipse.
That's right. During totality, it gets a lot darker. We don't have that 360-degree sunset, but we do see that dimmer light. It's not the right strength for this time of day, that's for sure.
So, Jeremy, I talked about you as a solar ambassador, eclipse ambassador. Can you tell me a little bit what that's about?
Absolutely. So the Eclipse Ambassador program is what allowed me to be here today. It's an amazing partnership between the Exploratorium Museum as well as funded by NASA and the Astronomical Society of the Pacific. And together we have an amateur astronomer, that's me, an undergraduate liaison, and it brings together two very different people, from intergenerational pathways, and then allows us to reach an audience that's underserved and low income to be able to educate about eclipses.
So the Exploratorium team and the Eclipse ambassadors have been here talking to people that are here on site, going out on train rides. It's just a wonderful experience, but it's probably getting pretty close to annularity down there in Valley of the Gods. So let's send it back to you guys.
Thank you so much, Rob and Jeremy. That was amazing to see what it's like in Ely, Nevada, and we're so excited here. If we look at the telescope here, we see in Valley of the Gods, we are also getting close to annularity. You see this U, and the moon keeps moving. As we approach annularity here, I'm very excited to welcome another guest. We have Cody Cly, who is a Dene astrophysicist who studies space dust. Cody, can you tell us a little bit more about yourself and your research?
Yes. So I'm from the University of Texas at San Antonio. I am a PhD student, so I study space dust. So what I study are just, stars that are just exactly like our sun, but they're slightly cooler. And a lot of these stars that are like that produced a lot of dust in the universe. And so my job is to go into the laboratory and try to recreate these environments and to the best I can and with the technology we have. And so I do my best to recreate star-like environments to actually help create certain types of dust species that might not be found here on Earth as well, but at the same time we are all made from space dust, and so this is why I study space dust, and I love it.
So is the sun our star producing space dust?
Yes, our star, our sun is our star, the closest star to us. And yes, it is producing dust at the moment, but we don't actually see it happening on a real-time scale.
That's amazing. Yes. Cody, what got you interested in studying astronomy?
What got me interested in studying astronomy was just, as a young kid growing up on a reservation, I saw the starry night sky every single night. And, sometimes you're afraid of the dark, but other times you're just fascinated by just seeing how many stars are out there. And, you just grow up seeing the same night sky. But then at the same time, every winter I would hear our creation stories, and those creation stories do involve how the stars were created and, how the night sky got its shape. And so a lot of times that would inspire me because I always ask the question, why?
And what are you excited about today?
Oh, today I'm excited about the annular eclipse because it is significant for a lot of, for our culture traditionally. It's an important time for us to be reverent and plan for the future. But at the same time, being an astrophysicist, for me, seeing this cosmological event happening on a local scale is just so exciting. As well, it's just a way for me to reconnect with my culture and who I am, and it's just something that I'm feeling right now in here, and like it's just all over right now, and it's
in
just
your heart and your mind.
Yes, it's just so exciting. So this is going to be my first annular eclipse. I've only seen partials in the past.
Me too.
Yes,
we got this, dude.
Yes.
Awesome. So thank you so much, Cody, for sharing your knowledge with us and your experience. It's actually getting a little cold here right now, which is surprising me a bit.
Yes.
So thank you so much. Now, as Cody goes to figure out how he's going to celebrate this eclipse, we invite you all to also find a way to experience this eclipse that is the most meaningful for you. As we are getting closer, I want to remind you to please wear your safety goggles and make sure that they have their ISO on them. All right, and so we are
taking
closer.
a look at the telescope image, and you can see, I think we are right at annularity. I can see the sun peeking through the other side of the moon.
Oh my gosh, it's a perfect ring.
Oh my goodness.
This is amazing.
This is beautiful.
I can't.
So the moon has not moved to the center of the sun yet, but you can see we are absolutely at annularity where it's coming.
It's definitely a complete ring. It's a little fatter at the bottom.
It's fatter, but it's moving so quickly. Like
Yeah,
I feel like it's
really
going
fast.
to. I know annularity here is going to last for about 4 minutes.
This is so cool.
Passing along pretty
Oh
quickly.
my gosh. So I'm sorry for those of you who don't have glasses. Let's check in with you and see our pinholes. Remember we were talking about pinholes. Now, what if you don't have a grid like I did? You can actually make a grid with your fingers. And so if you just hold your fingers, oh my gosh, if you just hold your fingers into a grid shape, you can start to see a bunch of
little rings.
They're like little baby ring lights.
Oh my goodness.
This is so incredibly cool. I can't even.
This is nature's selfie ring light here.
And so if you had to work from home or make content on TikTok or something, you might be familiar with ring lights. Oh my gosh, look at that.
Oh my gosh.
Oh, this
Okay,
is so cool.
as we look back at the telescope image, you can really see that there's variation in the amount of light across the sun. And of course, as the moon is moving, it covers different portions of the sun. And at the Exploratorium, we have a sound artist named Wayne Grimm who takes light information and converts it into sound in a process called sonification. Wayne is taking data from our telescopes right now and making a real-time composition that converts this eclipse into music. So we're going to take a few moments now to experience this eclipse through our ears.
Is that not the raddest thing ever? It's so cool.
It's better than Casper. Why do I like it better?
I don't know. Because it's new and exciting. It's different. You see the corona. You don't see the corona. You're seeing the edge of the sun instead of the sun's atmosphere. So you're seeing something different. Okay, I might ask you about that then. Okay. Oh, it's so pretty. It's so really good. It's a little talked about or something. It's really cool. That's our countdown to about going on. I like it in my hair. Do you see that? Are you trying to get a picture? It's really neat, isn't it? It's neat when you move. We make beautiful rings together. Hi, I'm back, and I've got a couple people who are here on site with us who just experienced an annular eclipse. So I'm going to ask them what they thought. What's your name?
I'm Lindsay. I'm from Salt Lake.
Awesome. And so have you ever seen an eclipse before?
I've seen a partial eclipse. I've never seen an annular eclipse. So this is my first experience seeing this.
And so what did you think? What did you notice?
I noticed the temperature. I'm chilly.
It's very cold.
I noticed I had to take off my sunglasses, put on my normal glasses, and my solar shield.
Yeah, so the quality of light has really changed, and it's very cold, which I didn't even expect. Thank you so much, Lindsay.
Thank you.
And who are you?
I'm Darcy from Pacific Grove, California.
Awesome. And have you seen an eclipse before?
I have actually. Was with you in Casper for the solar eclipse, which was amazing. But I like seeing the sun ring this time.
Right, so you're noticing that in this total solar eclipse, you see the corona, the outer atmosphere of the sun. On this, you actually see the edge of the surface of the sun. And you like this, but why did you like it better?
I think I didn't expect it to be so gold and so bright. These glasses really make the color beautiful, and so it's like you're looking at art as well as science, you know?
Yeah.
Beautiful.
And I noticed the ring itself was very solid, whereas in the total eclipse, you see that wispiness of the atmosphere.
Exactly. Yeah, I love this. I love being here, and then seeing it in this environment is fantastic.
You're right. Thank you both so much for joining us, and I'm going to now turn it over to Julie and Desiree.
Thank you, Robin. That was.
What did you think about that?
That was really incredible. I'm still kind of in shock from it, and I keep wanting to look up, and I shall not because I'm not wearing my goggles. But I'm really just kind of amazed at how spectacular it is that we can even witness a solar eclipse at all. It's kind of what we call a cosmic coincidence, because our moon is actually, its diameter is about 400 times smaller than the diameter of our sun. And so you might have some experience looking at something really far away that's giant, like one of these huge rocks, and you can actually use your thumb to completely block it out if you get it at just the right distance away. And that's actually what's happening with our sun and moon. And so Julie here is going to be my sun. And if you were to measure the diameter of the sun and also measure the distance that the Earth is away from the sun, you would create an angle. And this angle kind of tells you how much space the sun takes up in our sky. Now, if you were to measure the angle of the diameter of the moon and how far away it is from the Earth, it turns out it's the same angle. And so you can successfully block out the sun from Earth. Now, if we look straight on from at the sun, like as if we were in Earth, you come over here, then we are going to boop, boop, boop. You can just bring it closer and closer, and then that's about how far we are from the moon, and it perfectly blocks it out. But this is for a limited time only, folks, because it turns out that the moon is very, very slowly creeping away from us. And so in several 100 million years, we are actually no longer going to be able to see total solar eclipses here on Earth anymore. We are only going to be able to see annular or partial eclipses. So catch one while you can. Let's throw it back over to Robin and Eric.
Hi, I'm back with Eric, and I'm also joined by Troy Klein, who's the outreach coordinator for Parker Solar Probe. So we're all working together. We've got the scientists, we've got somebody doing outreach. Before I talk a little bit more, I just have to say that was amazing, and I'm cold.
It was fantastic, but it is colder than I expected it to be.
Yeah, the temperature really dropped.
It really did. I'm shaking a little bit, and then I was playing with my fingers and shadows and making circle shapes all over the ground. It was amazing to see this.
It was incredible. Again, I've seen 5 total solar eclipses, and this was spectacular. I am so excited and jazzed to be here, which was unexpected. So anyway, back to the topic at hand. We've been talking so much about NASA today, and I just think it's interesting to note that when NASA was first formed, they had a few things they really wanted to achieve for the first space agency. One was to send somebody to the moon. The second one was to send a lander to Mars. And the third thing was to send a mission to the sun. And it's taken so many years. We did the first 2 relatively quickly. Why did it take so long for us to get something to the sun?
It's because we didn't have the technology at the time to send a spacecraft that close to the sun. It's only recently that we've been able to develop the really actually complicated thermal protection system, the heat shields for the Parker Solar Probe. You know, Parker, when in the late 50s, when NASA was forming, Eugene Parker had just come up with the theory for the solar wind. He's the one who Parker Solar Probe is named after. He was actually around to see the launch of Parker Solar Probe. And wonderful spacecraft that went to prove his theories that he came up with at the very start of NASA.
Excellent. And talking about great scientists, Eric, I'm going to say you're one too. And I'm curious, what sort of got you interested in the sun? What was that thing that sparked your curiosity?
So I knew I was good and enjoyed science and math from an early age. And I remember as a kid seeing this thing called a cloud chamber. And in a cloud chamber, you can see the tracks of subatomic particles, things too small for the best microscopes. And yet you could see the tracks they made in those cloud chambers. And that just I found amazing. And now I build instruments that measure these charged particles moving at almost the speed of light.
That's amazing. You know, we have one at the Exploratorium. I think a lot of science museums have cloud chambers where you can see what he just described, these unseen particles that leave these beautiful trails across a sort of vat of vapor, if you will. So I'm a little confused, Eric. So now you're talking about outer space particles. How's that related to the sun?
So the sun accelerates some particles up to almost the speed of light. And those solar energetic particles are the most dangerous part of space weather. They're a danger to our satellites, they're a danger to our astronauts when they get beyond the Earth's magnetic field. And so understanding how they get formed is really important as we expand out through the solar system, especially with manned missions.
Right. So I imagine, Eric, after this mission and you've gathered all this great knowledge about particles, that you'll be ready to retire, or it'll answer your big question?
There are always more questions. I sort of see the universe as this enormous puzzle, and scientists are trying to fit pieces into that puzzle. But you fit one piece in, and that just points the clues to the next couple pieces that you can look for. It's a puzzle we're never going to solve, and this discovery of the universe is driven by curiosity, and curiosity is across all of humanity. It's common. And so, Troy, why don't you tell us some of the things that you're doing to connect curiosity and culture?
I would be delighted to do that. I'm so excited to be here to talk about this. We've been tracking for a while now the Makerspace program, which is a program that's been sweeping the nation now for years, where communities come together and bring technologies and they build all kinds of things and invent things together. And we thought, why not infuse these makerspaces with space science and heliophysics and many of the things that Eric and Robin have been talking about. And some of those tools that people create end up being 3D printing, augmented reality, and so forth. One of them is right here with us now, and this is a 3D printed model that students can also use as a teaching tool. We also, if you don't have a 3D printer, there are other ways to build models, and those models can be built through paper models. We have one here that you can download at APL's Parker Solar Probe website. Just do a search for it, you'll find it. And on the back, you'll find the AR experience. You can download this. It will make it look like a full-scale paper or full-scale model of Parker Solar Probe is right there in your living room or backyard.
Okay, so anyone with the 3D printer can print this cool copy of the probe. Now, Eric, we'll use this as a teaching. Where's your instrument on this thing?
So my instrument is on the back here. This section here, you can see the heat shield. That's really important. That's the reason why we have Parker Solar Probe. We keep this side pointed at the sun, and my instrument and most of the spacecraft hides in the shadows behind the heat shield.
Right, so why don't you tell us a little bit about Parker Solar Probe? When did it launch?
So it launched in 2018. We've been going around the sun regularly, and we use Venus actually to spiral in closer and closer to the sun. In order to get close to the sun, you've got to lose velocity. So we've gone 6 passes past Venus, and we've got one more before we'll lose synchronization with Venus. But after that one in late 2024, we're going to get to the closest approaches for Parker Solar Probe. We're going to be within 4 million miles of the surface of the sun. Just amazing. The data we're getting, even now when we're more than 5 million miles from the surface of the sun, is just fantastic. We're still trying to figure out what all it means.
Right, and we were just seeing a beautiful animation of how close Parker's getting to the sun. It sounds like far away, but it's actually incredibly close. And so I want to get back to you, Troy, because you were talking about the maker spaces where you're doing all these, amazing things, getting people to think with their hands.
That's right.
But this time you're doing things a little different. Tell me about that.
We have flipped the paradigm completely around. We've been working with the Indigenous Education Institute. Nancy Mary Boyd, David Begay have been on the show, and they said, why not take your makerspace space science program and turn it into place-based learning, which will infuse cultural values and norms of various cultures, including the Dene culture and cultures in Hawaii. Little Singer School that you're seeing on the screen right now is a school in Arizona where these wonderful Navajo children and Dene children are learning about the EASY mission, about heliophysics. They're learning about Parker Solar Probe and creating all sorts of new inventions on their own based on what the scientists and engineers from APL and NASA bring to them in their classrooms through things like Zoom.
So I find this so fascinating, right? So you're working in all these schools with a lot of different indigenous children, and instead of, usually we, educators, scientists, we create activities for the students to do. But this time the students are creating them.
We have completely flipped this around. So what happens now is that the students on the various indigenous communities within those communities are the thought leaders of today. They're the ones who are pulling together the ideas of how to merge culture, norms, values, language, merge that in with science and engineering concepts, and make an entirely new program called Maker Place. And that's what we have now. We have an Indigenous Maker Place program with up to 10 communities involved all over the United States.
I love it. That's awesome. Okay, so before I let this go, I just wanted to say there's a couple things I wanted to point out. In 6 months, there's going to be a total solar eclipse, and during that time, Parker Solar Probe will be flying through the corona, which is an amazing thing to keep in mind. This is going to be that close. So when you see the eclipse, you can think of Parker. And then also something really special is happening in December of 2024.
That's when Parker will start making its closest approaches. So it's an amazing year for heliophysics, for the study of the sun, starting with this annular eclipse, going through the total eclipse next year, and all the way to the Parker's closest approach.
Well, I love it. I'm going to hand it back to Julie and Desiree so I can play with some more pinhole shadows.
There are still interesting pinhole shadows here happening in Valley of the Gods. How you feeling?
I'm feeling really amazing. This is very shocking for me, and I'm having a lot of fun with my pinhole shadows, so I'm glad the camera wasn't watching me over here jumping around and playing.
Pretty great. My hands are freezing,
yes,
but my
I'm
heart
really,
is warm.
cold. My heart is warm.
I want to take one last look at the telescopes together if we can. And you can see that the moon keeps moving, and we are back to a partial solar eclipse here in Valley of the Gods. I want to say that it's a pretty incredible experience to see a donut in the sky. And as incredible as that was, as Robin mentioned, in 6 months, there will be another opportunity to see something very incredible. On April 8th, 2024, there will be a total solar eclipse, and most of North America will experience at least a partial solar eclipse. But those that are perfectly in line on Earth, perfectly in line with the moon and the sun, will experience a total solar eclipse.
It's going to be exciting.
Just like today with the path of annularity, there will be a path traced across the U.S. that will this time be a path of totality. And so the moon will be a little closer to the Earth on April 8th, 2024, and will completely block the sun. The path of totality will start in Mexico. It'll enter the U.S. in Texas. It'll move northeast up through Maine into Canada. And once again, the Exploratorium will be sending expeditions out, this time to Mexico and Texas, to broadcast totality to the world. If you want to experience a total solar eclipse, make a plan to be in the path of totality. Those who will see the moon completely block the sun, and that'll be a completely different experience than the one we had today.
Yeah, I am. I've never experienced an eclipse until right now. So I'm super duper excited to go to Junction in April because even though I haven't been there, I've seen footage from the Exploratorium. And so I've seen that when the moon blocks the sun completely, it gets actually very dark. And you can see all of the stars in the sky, and you can see a 360-degree sunset around you. And at the point of totality, you can actually take off your eclipse glasses and look at the sun and actually view its corona, which is the atmosphere on the sun. And so you can see some of those flares and prominences that we were talking about earlier with Dr. Collado Vega. And I heard that from other people that it gets really, really cold, and it got pretty cold here today. So I'm actually kind of scared to see how cold it's going to be in Texas. And something else that I missed is like sometimes you'll see something called Bailey's beads, right? Where like the moon's shape is going to affect the light that you see coming out from behind it. So is there anything that I missed?
No, I think you should get excited, and I'm super excited to get to experience it with you.
Same.
My friend.
You're the best.
I mean, and speaking of scary, like imagine a time before people understood what eclipses were. It must have been terrifying for the skies to suddenly get dark and for the sun to basically disappear.
Mm-hmm.
Over time, through observation of the skies, people further developed their understanding of what was going on, and they developed cultural practices and rituals related to this spectacular event. And now our understanding of the cosmos allows us to predict the exact second totality will start and end in any given location. This is just one example of how science helps us understand the world around us, and I hope you use this knowledge to plan and prepare for next April's eclipse. We will be in the path of totality, and we hope you'll join us. See you then.
Bye.